So collisions can be classified into three kinds. There is a perfectly elastic collision, then there is inelastic collision, and then you have got a perfectly inelastic collision. So these are three different kinds of collisions that we saw in the previous class. We saw the mechanism of a collision, how does a collision proceed, and we saw that in all these three kinds of collisions there will be a deformation stage. So the two objects which are undergoing the collision will go and they will hit each other and they will undergo some kind of deformations, and there will be a state of maximum deformation, and until that stage all the three will proceed in exactly the same manner. But what happens after that? Once the stage of maximum deformation is achieved, what happens after that depends upon what kind of a collision is it. Is it elastic? Is it inelastic? Is it perfectly inelastic? So what happens is that in case of an elastic collision, the objects, they try to regain their original shape and size, and they are able to do that 100%. Inelastic, they try to regain their original shape and size. They are able to do that to a certain amount, but not beyond, not 100%. Perfectly inelastic, they don't even make an attempt to regain their original shape and size. Now in all these three processes we have defined a ratio of we have tried to define a ratio. The ratio is the total impulse during the restitution part divided by the total impulse during the deformation part. When I talk about the restitution part, that is the part of regaining their original shape and size. So there is a certain impulse that the objects will feel when they are getting deformed, and there is a certain impulse that they will feel when they are getting reformed again into their original shape and size. So that part is called the restitution part. So there is a deformation phase, there is a restitution phase. Let me also try to define here. There is a deformation phase, from beginning of collision that is the moment when the objects just come into contact, from beginning of collision to the instant when the objects are deformed by the maximum amount. Then there is a restitution phase. It starts from the moment the deformation phase is over. So it's from the instant of maximum deformation till the instant the objects keep trying regaining their original shape and size. So once the objects stop trying regaining their original shape and size, the restitution phase is also over. That means if you have got a perfectly inelastic collision, there will be no restitution phase, because the objects do not make an attempt to regain their original shape and size. Now, what happens in these phases? So let's have a look at some equations here. Let's first of all deal with the deformation phase. So let's say we have the deformation phase. Okay, so what happens in this phase? There is an object A that was initially traveling with a velocity UA, and I can say A's mass was ma, so I just have to write the mass inside, and we can identify that this is object A from the subscript here. So there is this mass A, this object A of mass ma that is traveling initially with a velocity UA, and it experiences a force in the backward direction because of object B that was in front of it. That is how we dealt with the situation yesterday in that class, in the previous class. So there is a force acting on it in the backward direction, and let me write that force as D. D is for deforming force. Now that deforming force may be a function of time, so it may be more at some instance, it may be less at some other instance. So if I have to find out the total impulse of the deforming force, I have to integrate that deforming force with respect to time. And in the state of maximum deformation, this object A was traveling at a speed, let us say u, like this. So the state on the left gave rise to the state on the right here. So an object A of mass ma initially traveling with a velocity ua towards the right experiences a total impulse integral of d into dt towards the left hand side, and as a result its velocity becomes u to the right hand side. This is the entire interpretation of this figure here. So what equation can we write? In terms of equations, what I can say is ma times ua, initial momentum, plus the total change in momentum should give you the final momentum. But how much is the total change in momentum? Change in momentum is equal to the impulse, and because impulse is in the opposite direction, let me treat it as negative. Minus integral of d dt is equal to ma times u. This is equation number 1. And I'm going to take the right hand side as the positive x-axis. That goes without saying, the usual x-axis system that I'm taking. So this is the usual x, and that is why I have taken ma ua to be plus and this integral d dt to be minus. So this is one equation that I get. Now what happens in this same time to object B? So if you had object B, let's say there is an object B of mass mb that was initially traveling in the plus x-axis direction with a velocity ub, and it starts experiencing a force because of object A that was ramming it from behind. Now the force that object A will exert on object B will be always equal to the force that B exerts on A, and we have assumed it to be D, the deforming force. So the impulse acting on B will be in the forward direction, and it will be equal to integral of d dt. And as a result of this entire process, what happens is, now this guy B starts moving at the end of that process with a velocity u, because I'm looking at the state of maximum deformation, and that is when A and B are traveling at equal velocities. So this is u. So what equation can I write for this object B? I can say mb times ub plus integral of d dt is equal to mbu. This is equation number 2. So these are the two equations that I will end up with for A and B in the deformation phase. Now let's go to the restitution phase. So what happens in the restitution phase? In the restitution phase, you already have an object A somewhere whose mass is ma, and that was traveling in the forward direction at a velocity u, because this phase starts wherever this phase ends. So the ending stage here is equal to the initial state here. And still what happens is, now B is trying to regain back its original shape and size, so it is trying to push A back. So there is still a force on A in the backward direction, and that force, maybe I will label that as R, to say that it's the force during the restitution phase or the reforming force or something, So integral r dt is the total impulse experienced by this object A, and at the end of this entire process, we have got object A of mass ma traveling forward with a velocity va. So what equation can we write for A now? The equation that we can write for A is MAU minus integral of R dt is equal to MAVA, and that is probably equation number 3. And finally, what happens to object B? So there is an object B somewhere here. So there is this object B of mass mb, which was traveling with a velocity u in the forward direction, and it started experiencing the same force and so the same impulse in the forward direction. So you have got integral R dt in the forward direction, and at the end of this entire process, B has got a velocity Vb in the forward direction, and the mass of B is mb. So what equation can I have now for this object B? The equation that I'm going to have here is this: mb times u plus integral R dt is equal to mb vb. The total initial momentum plus the change in momentum, which is equal to the impulse, is equal to the final momentum. That's it. So now using these equations 1, 2, 3 and 4, 1, 2, 3 and 4, I need to find out what is that ratio that I'm going to define as the coefficient of restitution. So before proceeding, what is the coefficient of restitution? Coefficient of restitution called E is defined as the ratio of the magnitude of impulse of restitution divided by the magnitude of impulse of deformation. So in terms of symbols, what I'm looking for is integral of R dt divided by integral of d dt. This is the ratio that I need to find out, and if I find out this ratio, that's the answer for what E is. So let me take all these equations, keep them here so that I can see all of them in one go and try to solve. So this is 1, this is 2, and this is 3, and this is 4. In order to find out what are integral of R dt and integral of d dt from these set of equations, what you can do is maybe divide 1 by ma, because that will leave just a u term here, and from that subtract equation number 2 divided by mb. So when you do that, when you try to divide the RHS here by ma and RHS here by mb, only u and u will be left out, and when you subtract, those two u's will be gone. So you will get u and ub in the expression, you will get integral of d dt in the expression. That's alright, because we want the answer in terms of ua, ub, va and vb, but we don't want the answer in terms of this u, because this u we have no clue what it is. So what will that give us? This gives us on the left hand side, so we will have only ua minus 1 by ma integral of d dt minus, so there is a minus here, 2 equation number 2 divided by mb, so you will have ub minus 1 by mb integral of d dt, and all that will be equal to 0. So therefore you can simplify this. You now know that 1 by ma plus 1 by mb multiplied by integral of d dt is going to be ua minus ub. So what I've done is I've taken this integral d dt term to the other side, it becomes plus. This also integral d dt term to the other side, it becomes plus. And I will get this term on the right hand side there. I've switched the sides. So I bring that RHS to the LHS here, and this LHS ua minus ub goes over to the RHS here, ua minus ub. So I've got the value of integral d dt. Then next for r dt again I can do the same thing. So what I can do is maybe equation 4 divided by mb minus equation 3 divided by ma. And I'm doing that because what will happen is if I try to divide 4 by mb and 3 by ma, only va 4 by mb here, so u will be left here, and 3 by ma, u will be left here, and those two u's will be gone if I subtract. So what will happen is you will have 1 by mb integral r dt, 1 by mb integral of r dt, and this minus will become plus. So plus 1 by ma integral r dt is equal to, and on the right hand side what is it that you're going to get? Vb by this entire RHS by mb, so only vb will be left, vb minus, and here only va will be left, so va, and that is going to give you 1 by mb or 1 by ma plus 1 by mb integral of r dt is equal to vb minus va. And you can easily find the ratio now. So when you try to find the ratio, you will get E as, because E was defined as integral of r dt by integral of d dt. So since E is equal to integral r dt by integral of d dt, therefore E is equal to, so I keep this guy in the numerator, this guy in the denominator, and this entire term 1 by ma plus 1 by mb will go off, so I don't want that. So on the right hand side this guy should be in the numerator and this guy ua minus ub should be in the denominator. So you will have vb minus va divided by ua minus ub. Now these are velocities. So vb, va, ua, ub, although I am not using arrowheads over them, they are velocities, but I prefer to write this expression for E in terms of speeds. It's more intuitive in terms of speeds. So if you want to write E in terms of velocities, fine. So then you will have to write VB, VA, UA and UB here with the proper signs. You do that and you will get E properly. Otherwise you deal with just speeds. And how E can be written in terms of speeds is E is equal to the relative speed of separation. So the speed at the objects, the speeds at which the objects are going to separate, that should come in the numerator, divided by the relative speed of approach, the speed at which the objects are approaching each other. So E should be that ratio. Now how do we write an expression for E? If you know the velocities and if you insist on inserting everything with proper sign, you can use this equation blindly. You do that and you will get the right answer for E. But then you will have to keep in mind the order. So in the numerator it should always be VB minus VA, and in the denominator it should always be UA minus UB. If you keep in mind that order and you insert everything with the signs, you will have the right expression for E. Otherwise, if you insist on using speeds, then you will just have to see how a few cases work and you will get the feel for it.